Hello, guys.
Hello, everybody.
Everybody's
Hello.
back.
Oh, everyone.
So, how's your weekend?
It was okay. Nothing special.
It's good.
It's cold.
Same old,
Cool.
same old.
Mhm.
Just playing with the kid.
Oh, but you still got puzzle done.
Yeah, he's been great on weekends lately. He takes his nap at 2 o'clock. So from like 2 to 4, I'm free. Although he woke up a little early, we had to go to my sister-in-law's house. So I finished part 1 before we went to my sister-in-law's, and had to finish part 2 when we got home.
All right. I couldn't finish it yet. Yes, this one. Yesterday I finished the part 2 of day 11. Because that took me a little bit while. Yeah.
Good job, good job. Yeah, we're making good progress. We're almost halfway.
All right, well, let's go through, I'm gonna share this screen we're now going over the questions for day 11 and 12 today, and the answers for day 5. So, day 11, Dumbo octopus. I'll read this one. You enter a large cavern full of rare bioluminescent Dumbo octopuses. That's an actual thing. That's a link.
Yeah, it's an actual octopus. And it looks like an elephant kind of.
Wow. Oh, it's a
There's
YouTube video. Wow. Someone's gonna be watching a YouTube video of us watching a YouTube video. Oh, that's cool.
YouTube section.
Wow.
Yeah, it's got a little.
It's cute.
It looks like it's flying with its ears, like Dumbo.
Yeah. So they discovered this, I'm guessing, that after the Dumbo.
Yeah,
came out.
probably.
Yeah. Yeah, it's good.
Cool. Oh, 2 to 5 years. Anyway, back on topic. So they seem to not like Christmas lights in your submarine, so they turn them off. So you turn them off for now. I'm like, how do they let you know? Do they point at it and say no?
We can communicate. Aquaman.
Yeah.
I'm not Santa Claus, I'm Aquaman.
It made more to the story. Anyway, there are 100 arranged neatly in a 10 by 10 grid. How convenient.
Very organized octopuses.
Yes. The marching octopi. Or octopuses, I guess it says in here. There are 100 octopuses arranged in 10 by 10 grid. Each octopus slowly gains energy over time and flashes brightly for a moment when its energy is full. Interesting. Although your lights are off, maybe you can navigate through the cave without disturbing the octopuses if you could predict when the flashes of light will happen. Oh, so the octopus flash, huh?
Yeah, so we're gonna use their light to navigate so that we don't have to disturb them.
So I guess maybe it bothers them that you have your lights on because you're out of sequence.
Oh, yeah.
Could be. Or because you're not flashing, you're like steady on, like, no,
Mhm.
smash. Anyway, each octopus has an energy level. Your submarine can remotely measure the energy level of each octopus. This submarine.
It's amazing.
Amazing.
Do everything.
All kinds of data, no answers, but a lot of data. For example, and then the entire, was it 10 by
10 by 10.
10 grid? Oh, that's right. They said it was a 10 by 10 grid. The energy level of each octopus is a value between 0 and 9. Here, the top left octopus has an energy of 5. The bottom right one has an energy of 6, and so on. You can model the energy level and flashes of light in steps. During a single step, the following occurs. First, the energy level of each octopus increases by 1. Then, any octopus with an energy level greater than 9 flashes. This increases the energy level of all the adjacent octopuses by 1, including octopuses that are diagonally adjacent. If this causes an octopus to have an energy level greater than 9, it also flashes. This process continues as long as new octopuses keep having their energy level increased beyond 9. However, an octopus can only flash at most once per step, and all these are steps. So finally, any octopus that flashed during this step has its energy level set to 0 as it used up all its energy to flash. And so these are the three things that happen in a single step. Adjacent flashes can cause an octopus to flash on a state, even if it begins that step with a very low energy or very little energy. Consider the middle octopus with 1 energy in this situation. And so we got an outer ring of 1s, a kind of an inner ring of 9, and inside the inner ring is an octopus of energy level 1. But then the combined influence of all the octopuses around that one going off, they each contribute 1 to that middle octopus as it goes off. So the top left contributes 1, the middle top contributes 1, the left top contributes 1, and so on. And there are 6, 7, 8 around them, right? And so you have at the step, everything increases by 1, right? So that's why the corner went from 1 to 2. And then the inside, the very center one that we're focusing on goes from 1 to 2 as well, right? And so everything should have either 2 or I guess 10, right?
Yeah.
Basically a point where they flash. And because those octopi in that middle ring have flashed, they each will contribute 1 to its neighbors. And the one that we're focusing on right now is the middle. So on the top left one flashes, it contributes 1. So it goes from 2 to 3. And then when the one above it flashes, it goes from 3 to 4. And then when the upper right flashes, it goes from 4 to 5. And so on.
8 times.
Yeah. And so at the end of it, it goes from 2 to 10, right? Because they all contribute 1. And so then the middle one then is now above 9 as well. So now it
Flashes
flash.
too.
Yeah.
Wow.
Yeah, lots of flashing. So after this step, however, since they all got set to 0 and they all flashed and they used up all their energy, and now they're like, oh, dazed and confused. After step 2, they'll get bumped up to 1. An octopus is highlighted when it flashes during a given step. Here's how the larger example from above progresses. And it gives you, so a sequence. The first, after step 1 is pretty self-explanatory. Nobody flashed. Everything just increases by 1.
But we have some 9s now, so
Yeah, we have some
they're gonna
9s.
flash during the next round.
So in the next round, remember first we're gonna, at each step, increase everything by 1, find out which one has flashed. Basically which one is 9 or greater than 9. And then so those go off, and then all those also affect their neighbors to go off. And then based on that, now you know which ones have flashed, right? Because they're over 9. And after you've marked all the ones that flash, you can set them all to 0. So you can see the ones that are 0 here, and then life moves on because now you have other 9s in your grid, and so on, and so on, and so on.
So make sure that each octopus can only flash once in a given step. If it flashes in that step, at the beginning of the next step, it's going to be at 0. It can't flash and then get flashed by other octopuses and flash again in one step. That's not going to happen.
No.
After it flashes, it goes to 0.
So after 10 steps, there have been a total of 204 flashes. Fast forwarding, here's the same configuration every 10 steps. So at 20, at 30, at 40, at 50, at 60, and so on, until you get up to 100. After 100 steps, there have been a total of 1,656 flashes.
A lot of flashes.
A lot of flashes. It's a lot of flashing.
I wonder what the timing is on this. Like, how long does one step take for these octopuses?
Yeah, maybe it's like a 1 step forward, flash, 1 step forward, flash. You actually take no, I don't know. I don't know if they're like just like in place, in which case it'd be only usable light for whatever, area that they light up, but I don't know.
Does the puzzle is also 10 by 10?
Yes.
Yeah.
Yes.
Okay.
Yeah. So this one's nice because the sample input is the same size as the real input.
So given the energy levels of the Dumbo octopuses in your cavern, simulate 100 steps. How many total flashes are there after 100 steps? Let's That's the question.
How many total flashes? And remember that adjacent octopuses in this puzzle also includes diagonal ones.
Yeah.
So most octopuses will have 8 adjacent octopuses, unless they're on the sides, and then they'll only have 5, or in the corner, they'll have 3. But I remember one of our previous puzzles had to deal with adjacent elements that didn't include diagonals. So remember, this one does.
Okay.
All right.
Any questions?
Was it clear enough?
I think so. I mean, I guess some of us have the ability of hindsight, because some of us have already finished the puzzle. But I think for me, the confusing thing was trying to figure out proliferation. How far do I
Continue
influence
flashing.
out,
Yeah.
right? Yeah, I don't want to give away too much, because I know some people want to really tackle this from fresh, but I would say, that's the general ballpark of where my challenge was trying to contain the explosion of flashing to the parameters that were given. Anyway,
All
cool.
Let's see the next one.
Yeah, let's go to 12. Ooh.
Okay, 12.
right.
Oops, let me refresh. Okay, passage pathing. Who wants to read this one?
Okay, I'll go with this one.
Oh, thank you for it.
Right. Okay, passage passing. Visual submarine subterranean subsystems subsisting suboptimally.
Yes.
Alliteration.
Subsisting.
Yeah.
Suboptimally.
5 sections.
The only way you are getting out of this cave anytime soon is by finding a path yourself. Not just a path. The only way to know if you have found the best path is to find all of them. Fortunately, the sensors are still mostly working, and you build a rough map of the remaining caves. Your puzzle input. For example, we have start A, start B, AC, AB, BD, A end, B end. This is a list of how all of the caves are connected. You start in the cave named start, and your destination is the cave named end. An entry like BD means that cave B is connected to cave D. That is, you can move between them. So yeah, you can move from B to D or from D to B, either way. So the above cave system looks roughly like this. We have start connect to A and lowercase b. We have A connect to lowercase c and lowercase b and end. We have B connect to lowercase d and end. We have a small map basically. So your goal is to find the number of distinct passes that start at start and end at end, and to not visit small caves more than once. There are 2 types of caves: big caves written in uppercase like A, and small caves written in lowercase like B. It would be a waste of time to visit any small cave more than once, but big caves are large enough that it might be worth visiting them multiple times. So all passes you find should visit small caves at most once, and can visit big caves any number of times. Given these rules, there are 10 paths through the example cave system. For example, one of them, the first of them could be, we start at start, go to A from there, go to B from there, go back to A. Since A is a big cave, we can visit multiple times, and go to C from A, and go back to A one more time, and from A we can go to N. It's not the best route, but it's one of the possible routes we can take, so that we must include any possible mixture of the caves that lead from start to end. Yeah, each line in the above list corresponds to a single path. The caves visited by that path are listed in the order they are visited and separated by commas. Note that in this cave system, cave D is never visited by any path. To do so, KV would need to be visited twice, once on the way to KFD and a second time in returning from KFD. And since KV is small, this is not allowed. I think it corresponds to this point. So as it's mentioned, if you start from start, go to B, we are visiting B once. And if you go to D, we have to come back. So on our way coming back, we are visiting it second time. But that's not allowed since the KB is a small cave, we can visit it only once. So we have a slightly larger example here, DC end, HN start, and so on. And we have 19 possible passes through it that are as follows. As given here, we have a mixture of caves that lead from start to end, all the possible caves basically. And finally, this even larger example has 226 paths through it. We have another list of caves, and possibly we have a 226 paths through it. How many passes through this cave system are there that visit small caves at most once? There probably will be given an input like this, which will show the linkage between two caves, and we have to find the possible caves, or possible passes between those caves. Probably in part 2, I did not go to part 2 yet, but I am assuming that we'll have to find the most optimal one probably in the part 2. But in this part 1, we have to count how many possible passes are there.
Sounds like a good guess.
So
I like that they gave us 3 different sample inputs for this one. That seems really useful.
Yeah.
big cave is just the capital one.
Yeah, big caves have
Yes.
capital letters. And can you scroll down to the final sample input?
Yeah.
So I think it's worth noting that on the final sample input, that's more realistic to how your actual input will be. It's not just going to be single letters. For example, it'll be like lowercase fs or capital dx. So it's not just capital or lowercase single letters, it's combinations of letters. But it still represents one cave.
So then
like
the second one is not a big one. HE dash.
HE is a small cave, but it's connected to a big cave, DX. DX is a big cave. So each cave can have multiple different connections.
Okay.
But are any of those letters reused? Even if you did only the first letters, I think you might be able to get away with it. So I don't think.
On that one, maybe. I don't know. How
On the
about
puzzle set?
How about the actual input?
Can we see? Yeah.
Do you guys want to have a look on my puzzle input?
Sure. Let's see if there are any repeats.
Yeah.
No, J's, JC, JY. They're both J's.
Oh, yeah, you do have JC and JY. So that makes it a little harder.
Okay. All right.
This is day 12. I like this puzzle. I did not solve it yet, but it seems more logical than the other stories we had.
Got something against the Dumbo octopuses? Those are cute.
The flashing Dumbo octopus.
Oh yeah, the flashing Dumbo octopuses.
Octopus.
That swim in a 10 by 10 grid.
When I see the first start and AV, I was like, oh, if the puzzle is shaped like that, it's gonna be a pain to follow it.
If it was shaped like the map that they did. How am I gonna
Turning off lights in order not to disturb octopuses and solving a problem so that you can go through there using the lights.
Yeah.
I don't know.
I don't know how your sensor can sense all of the other caves in the cave system.
And not tell you where to go.
Yeah.
It's sophisticated,
Do you have
but
like
not that
little
sophisticated.
mini submarine drones that are flying out in front of you?
Yeah. None of them are telling you,
this
oh, I
one
made it to
seems-
the end. And here's how I went.
All right, seems
I
like a
think-
fun puzzle.
Yeah, for me, a possible approach, I'm not going to reveal much, but possible approach would probably be to check all the possible combinations of those caves and filter out the ones which do not meet the requirement of visiting the small cave once or something like that. Yeah.
To me, this puzzle seems like one that you could probably find in like a data structures and algorithms course. It seems like there's probably like a few different algorithms you can find to find the most efficient path, or to find the number of total paths even. I don't know any of them though, so it'll be fun.
I don't know if it's good. I don't want to say anything. Yeah. Well, we'll save it for discussion when we go over the answers.
All right.
All right.
Thank you for
Cool.
reading, Farouk.
Thanks, man.
Sure.
And so now today's day 13.
Oh, yeah.
So let's see who wants to cover that one.
I guess I'll do it. Okay. You ready?
Want me to cast it? You got it?
Yeah, I'll take care of it. All right, can you see my screen?
Yep.
All right, day 13, we're more than halfway. Transparent origami. Okay, this sounds fun already. You reach another volcanically active part of the cave. It would be nice if you could do some kind of thermal imaging so you could tell ahead of time which caves are too hot to safely enter. Fortunately, the submarine seems to be equipped with a thermal camera. Of course, it has everything. When you activate it, you are greeted with, "Congratulations on your purchase. To activate this infrared thermal imaging camera system, please enter the code found on page 1 of the manual." Apparently, the elves have never used this feature. To your surprise, you manage to find the manual, of course. As you go to open it, page 1 falls out. It's a large sheet of transparent paper. The transparent paper is marked with random dots and includes instructions on how to fold it up, your puzzle input. For example, 6, 10, 0, 14, 9, 10, and so on. And at the bottom of our sample input, we see fold along y equals 7, fold along x equals 5. Okay, I'm a little confused, so let's keep reading. The first section is a list of dots on the transparent paper, 0, 0. 0, 0 represents the top left coordinate. The first value, x, increases to the right. The second value, y, increases downward. So the coordinate 3, 0 is to the right of 0, 0. And the coordinate 0, 7 is below 0, 0. The coordinates in this example form the following pattern, where this number symbol is a dot on the paper and a period is an empty, unmarked position. Okay, so we have this grid here that has all of these number symbols and periods. And remember, the number symbols are representing a dot on the paper. So these are all of the dots on the paper and their position. Okay. Then there is a list of fold instructions. Each instruction indicates a line on the transparent paper and wants you to fold the paper up for horizontal, y equals ... lines, or left for vertical, x equals some number of lines. In this example, the first fold instruction is fold along y equals 7, which designates the line formed by all of the positions where y is 7, marked here with these hyphens. See this line, that's the y equals 7 is where we're going to fold it right here.
So the 0.
Yeah.
0, 0.
Okay. Because this is a horizontal line, fold the bottom half up. Some of the dots might end up overlapping after the fold is complete, but dots will never appear exactly on a fold line. The result of doing this fold looks like this. Okay, so now we see here, look, if we look at the pre-folded one, we don't have any number symbol in the 0, 0 space. But under the fold line, we have one here. So now this one is going to get folded up to go to the top. And all of the ones down here are going to get folded up to their corresponding position on the top now. So now you're combining the number symbols from the bottom and the number symbols from the top. So now our grid is half the size, but we still have all of the same number of number symbols. I don't see any overlapping. Do any overlap? Like a number symbol on top of a number symbol? Yeah, it says some of the dots might end up overlapping after the fold is complete. Okay, but dots will never appear exactly on the fold line. Okay, so the fold line should never have any dots on it. But after they fold up, some can overlap. It looks like this one and this one are going to overlap.
Yeah.
So we might end up with fewer number symbols than we had before if they overlap. Okay. Now only 17 dots are visible. Okay, how many did we have before? Did it tell us?
No, I'm gonna guess 18.
Yeah, maybe. Now only 17 dots are visible. Notice, for example, the 2 dots in the bottom left corner before the transparent paper is folded. After the fold is complete, those dots appear in the top left corner at 0, 0, and 0, 1. That's what I just showed you. Because the paper is transparent, the dot just below them in result at 0, 3 remains visible, as it can be seen through the transparent paper. Also, notice that some dots can end up overlapping. In this case, the dots merge together and become a single dot. The second fold instruction is fold along x equals 5. Which indicates this line right here. So notice that there are no dots on that line. That's convenient. Because this is a vertical line, fold left. Okay, so we're going to overlap this side onto this side. Because this is a vertical line, fold left. And now we end up with this really convenient looking 0. The instructions made a square. The transparent paper is pretty big. So for now, focus on just completing the first fold. After the first fold in the example above, 17 dots are visible. Dots that end up overlapping after the fold is completed count as a single dot. How many dots are visible after completing just the first fold instruction on your transparent paper? I'm going to check out my puzzle input, see what it looks like. That is a...
Oh,
I'm still scrolling.
it's a big paper.
That's a big paper. And wow, we've got a lot of instructions here. But for part 1, I only care about the first fold instruction. So then I can guess that we will use the rest for part 2. So I need to fold my paper 1 time on this x equals 655 line. So I'm going to do so that's going to be, okay. Whew. This one seems fun.
But can we go back to instructions real quick?
Sure.
Go back to the top of the puzzle. So we have this manual, and the manual is looking for a code. Also, the first part, we're not getting a code.
Yeah. So second
First part, we just get the number that are still visible. Okay. So hopefully by the end of this puzzle, I guess we're gonna end up with a number.
Yeah, we got to get the thermal camera working. All right. So we have to find out how many dots are visible after the first fold.
I'm guessing that square is a 0.
Oh yeah, I'm guessing this one right here.
Somehow we need to get a number.
Yeah,
on
we'll
this,
have some
right?
kind of code at the end of it. I wonder what it's going to be.
Because I don't think like
Or
the
it could
thermal
just be-
imaging camera company is going to be like, oh yeah, these guys are going to be programmers, so we'll just have them count dots.
Yeah.
So at least with the folding paper in the real world, you can actually fold the paper and get something out of it at the end, and hopefully, it's something that you can type in. But I think, oh, how many dots are visible now? It's kind of a weird thing to ask. Well, the whole thing is a weird thing
Well,
to
it
ask.
could be how many dots are visible after you do all of the folds.
They're gonna
Then you can
fold
just
up
hold it
in
up.
light.
It's probably going to be just a little card at that point after you fold it 10 times or
Maybe
however
any
many.
sheet. Because the puzzle is quite big.
Yeah, I'm going to fold it 12 times, so it's going to be quite small after 12 folds.
Isn't there a thing where like you can only fold a paper X amount of times?
I guess it depends on the size of the paper.
No, even with the size, well, even if you get the thinnest paper currently available that is currently considered paper, I think there is a theoretical limit, like 12 folds or something like that before, like, because each fold you're doubling the width, right? And so at some point you're going to be trying to fold over like a 1/2 inch ream of paper.
Yeah. But if you have like a giant paper that's like the size of a blanket, then it might be easier, right?
Well,
If it's really thin and really wide, you can keep
folds
folding it a
also
little bit
get-
farther.
the folds also get less accurate as well, right?
Yeah.
Because you're not on a single seam anymore. Now, like the
It's on
digits
a
will have to be
bend.
far enough apart as well when you do your. Anyway,
All
reading
right,
too much
well,
into
we're
it.
gonna do some origami to get our thermal camera working.
cool.
All right, good
Day
luck.
13, so that's 11 through 13. All right, and now for the second part, we're going to be going over our answers for day 5. Start with going over the question itself. Did you want me to cover it, or did one of you guys want to cover it? Alexi, do you want to cover it?
I can read it, yeah.
Do you need me to share, or do you got?
I will consider it. All right. Day 5, hydrothermal venting. You come
Okay.
across a field of hydrothermal vents on the ocean floor. These vents constantly produce large opaque clouds, so it would be the best to avoid them if possible. They tend to form in lines. The submarine hopefully produces a list of nearby line of vents, your puzzle input, for you to read. For example, 0,9, 5,9. How do you call this? Just arrow
Goes to,
goes to, okay, goes to
0.9 goes to 5.9.
Okay.
So you end up with just a bunch of lines at the end of this, right?
Yeah, it's just
Vertical and
lines.
horizontal lines.
Gives you the starting point and the ending point of each line.
Right.
Yeah, but there are some
Diagonal.
diagonal lines, like 80 to 08 is actually a diagonal. line.
Right, that one,
Well,
yeah.
But it does say for now, only consider horizontal and vertical. So
Exactly.
you can ignore those for now.
Each line
For
of-
now.
For now.
Big hint.
Each line of vents is given as a line segment in the format x1, y1 goes to x2, y2, where x1, y1 are the coordinate of coordinate of one end, the line segment, and x2, y2 are the coordinates of the other end.
Looks like there's a typo there. It should be
Mm,
next
right.
of one end of the line segment. You missed an of.
Let's try to skim over the question because we're going to be spending quite a lot of time on this
Okay.
question, I believe, especially with part 2.
Yeah.
So so do you remember what you did on this one? I mean, what was your approach to this?
Okay, yeah, so I couldn't solve it. I could solve only with my sample, but
Okay.
then when I try to run actually the actual puzzle, then I get screwed.
Okay.
Why? Because I didn't look at my puzzle right away.
Uh-huh.
I just played with the sample, and then it was 10 by 10.
Yeah.
So my idea was to actually, this would be 0, the next one 1, 2, 3, 4, 5, 6, 7, 10, then 11, until
So you
10.
flattened it.
And then, so I was just reverting this, I was just joining, and then reverting was like 90. And then this one was 95, okay? Then this, you do 95 minus 90 is a line of 5,
Sure.
right? So then you could go at the bottom and do 90 to 95, place 1. And then every time you were doubling, every time these guys was matching with that one, then it was working. It's like just very smooth. But then there is a big but. When you look at the puzzle is not 10 by 10.
Oh, I see. Big numbers. It looks like 1,000 by 1,000. Probably.
This screws everything. So I can try to. Do you want me to show my code?
Yeah.
I can try to show my code.
I see numbers up to 949. So I'm guessing
After you saw the
9,000.
puzzle input, your code betrayed you, right?
Yeah.
The sample betrayed you.
Do you see my
That
code?
happens sometimes.
Yeah.
No, I still see your
Oh,
your
Oh,
puzzle
yeah.
input.
I'm gonna share.
All right.
So, as I said, I tried actually on the day 5, the actual day 5. So I did exactly what I just told you 1 minute ago. Then I couldn't solve it. So I was like, okay, let's just comment it, then just put it at the bottom. And then yesterday I tried to spend 2 more hours on it. And then I figured at the end, I exactly did the same thing as I did last time. Which I was looking at it. I think it was like, damn it, I'm doing the same task.
At least you're consistent.
Yeah. Well, so that was the format of, the format was a little different though. The format of, so it was a big array with every line got an array. And then this was x1, y1, y2, yeah, y2. So again, this one, instead of trying 100, I tried 10,000 array, but it didn't work. So that was the approach. And then I couldn't come up with any other ideas.
Interesting.
I'm really curious, like, what did you guys do?
Well, do you want to see mine first then, since I did JavaScript?
Yeah, go ahead. It's funny, like I did seriously exactly the same. If you place the code, just the variable are different, but then it's exactly the same.
That's great.
Creatures of habit. It's hard to fight too. It happens. You'll see some of it in my code as well, where I'll try a different approach, but then like your brain always wants to try to gravitate to what it's used to, right? And so your old code starts to creep back in, like, oh, maybe that was the right way. No, we said it was wrong. We can try something different. Yeah, it's hard.
Let him go there.
Yeah, that's why you're again. It's comfortable.
Let him go there.
Or like, oh, but I was so close before. Only this thing was different. And then you try to solve that thing in 2 hours later. You're like, oh, I don't want to do that. And then you start coding here, but then you start going back there, and start going back. Oh, but maybe this is a good answer for that part that was missing. Anyway, go ahead. Sorry.
So can you guys see my screen now?
Yeah.
All right, just to show you, my puzzle input is 500 lines. So I have 500 different line segments. So let's see the code.
Well, before we get into it, what was it that we were trying to find?
We have to find the number of places where lines overlap,
Okay.
where lines
Overlap,
intersect or overlap.
Right.
More than once, right?
More than once.
Yeah, it could be 2 lines like completely over each
intersect
other.
would be-
Then there would be
yeah,
multiple
these
points
two
on the
lines.
same lines, right?
Yeah,
So it is overlap. It literally is how many points overlap.
yeah, you're not counting how many times they overlap, you're just counting how many places have at least one overlap.
Right.
All right, so here's my puzzle import. Actually, I had a little bit of some fun issue switching from Windows to Mac. I think it's probably with my rejects here, but I was able to quickly solve it by just commenting out my filter here that I needed on my Windows, but I did not need here on my Mac.
Okay.
So anyways, after that,
Only the even ones.
yeah, I think I had like some extra random lines on my Windows one. It was, I don't know.
Oh, because you're doing, you get extra lines because you're
my rejects is bad.
doing both the R's and the N's as a class instead of as a single item. So it's replacing all the R's and then it's replacing all the N's.
I just need to get rid of those. That should take care of it then, right?
Yeah, but then now it won't work on
Yeah.
Mac. So anyway,
All right. Well, anyways, after that, my puzzle input is going to look like this. So pretty much exactly like how Alexi just showed. And we did it the same way. We're going to have an array full of subarrays with each point. So x1, y1, x1, x2, y2.
Yeah.
you put a star after your dash line. I was gonna say you could put a range limiter on your R. Put like a star next to your R, which is 0 or 1 or 0 or any R's. This is on the, never mind. My brain was still trying to like,
for my rejects.
yeah.
Okay, yeah.
But
You're still on that. I
Yeah.
moved on.
Couldn't leave a puzzle alone.
Okay, now I think maybe this one will help. Maybe this could help Alexi. I think Alexi tried to do this, but he was setting the length for his grid.
Right.
Whereas I just initialized a grid as an empty array. So this is going to be my grid, which will show pretty much the map of hydrothermal vents, was it?
Mhm.
On the ocean floor,
So what,
and the locations of the lines and the overlaps.
so just a quick overview as to what we're gonna be looking at in your code. What was your approach to this one?
So my approach was pretty much just to go through, I'm gonna loop through my entire array.
Mhm.
I'm gonna figure out exactly where each line is.
What do you mean by figure out?
So based on the values, the X and Y coordinates.
So you're actually gonna put it on the grid.
I'm gonna put it on my grid. So my grid right now is an empty array.
Mhm.
It's gonna be, it's gonna end up being a grid. It's gonna have all of the rows, and inside each row will have all of the points.
So you're gonna predetermine how many rows and columns are gonna be?
No, I'm gonna have a lot of empty elements.
Oh, okay.
If we want to skip ahead, I can show you what my grid will look like at the end. This is what my final grid actually looked like for the sample input. So I had a lot of empty elements. So here's row one, I had 7 empty items, and then I had 1 line segment.
Okay, so when you say empty items, are they just null? Are they, like, how do you know it's empty and just not that one is the first element?
Well, I don't know about other languages, but in JavaScript, you can initialize an array, and you can set something as, for example, the 3rd or 4th element in that array, where everything before that can be empty.
Ah, you have a holy array.
Yeah.
Okay.
So I didn't set anything here. It's really nothing, but I have an element at this index in the array.
Gotcha.
And so, yeah, so my grid ends up looking exactly like it did on the Advent of Code website for their sample input. Where I
There's a
have
word for it. It's
one-
called like sparse array. I think that's the word, the technical word for it.
Does it exist in other languages, or is it? unique thing?
Technically, it should, because arrays are supposed to be fixed length, but
Okay.
there's a lot of gap or leeway it's given to these terms.
Okay. All right, well now, like I mentioned before, I'm gonna loop through my input, and just to make it easier to read, so I don't have input I00, input I01 everywhere, I'm gonna clarify those by putting X1, Y1, X2, Y2. So I'm just grabbing each point of the line in that row for my input. Now I'm gonna check if it's a vertical line or a horizontal line. So if the X's are equal, it's gonna be a vertical line. If the Y's are equal, I'm gonna have a horizontal line. Now I wanna see which one of those values, if X1 or X1 or X2, or sorry, if it's a vertical line, that means the X's are the same, but the Y's are different. So I wanna start at the smaller value. So I'm gonna get my start point using math.min of my Y values to get the smaller value. And now I'm gonna loop through the difference between those. So I'm gonna use math.absolute Y1 minus Y2, because I don't know which one's bigger at this point, if it's Y1 or Y2, and I don't want a negative in my loop. So I'm gonna use math.abs to get the absolute value, so that I'm gonna loop that many times. For example, if the line segment is 3 points long, I'm gonna loop 3 times. So 1 time for each point in the line. Now I'm gonna set, just to make it convenient, I'm gonna set my Y as my start value plus J, because it's gonna increase every time until it gets to the end of the line, the Y2.
Right.
And now, if I don't already have a subarray for that row, so for that Y value in my grid, if that subarray does not exist, I'm gonna create it. Just an empty array at that index in my array. You follow? So my array may have empty indexes, empty rows even. Like, for example, here, you see 4 empty items. That means for 4 whole rows, there's nothing. But then I can create a row at a specific index after that. So I'm gonna have a lot of empty indexes in my array, and that's okay, in JavaScript at least. And now that I've created my array for that row, if that row didn't exist, now I'm gonna set my point in that row, my X value. So for this one, I have to check. If I already have a value there, then I'm gonna increment that value. If I don't have a value there, I'm gonna set it as 1, because now I have a line crossing over that point. So this was for my vertical lines. And it's the same thing, except for horizontal lines, just my X's and Y's are switched.
Okay, so you have basically at the end of this large tapestry of points,
Of points.
and you're only counting how many times each point was relevant, right? So
Yes.
it's a line.
Yeah, so here,
It's the first time a line appears, it'll just be a line of ones.
yes, exactly.
But you're doing increments so that if at any point one of those lines was already a 1, it turns into a 2. If it was already a 2, it turns into a 3. So you're incrementing, starting. So you could have done the same thing, but you start with all the zeros. So yours would have been the same. Whereas if there was a line, you don't even have to determine whether there's something there or not if you already start out with all the zeros, because you initialized from the get-go, whereas Scott initialized as he was processing through the numbers. But you just have to increment.
Yeah.
With one of the points is between the beginning point and the ending point, you just increment by 1.
Yeah, so I think the main thing here is just my inner loop here. I'm just looping for every element in that line. So first I have to get my start point, and then this was one of the keys here is math.absolute to get the length of that line. All right, and then after I have my grid, I'm just
Do you
gonna,
need the absolute if you already know which one is the lower number? Can't you always go up higher number minus the lower number? I guess unless you were dealing with negatives, but I don't think we are in this
well, the
one.
way I got my lower number, I don't really know which one. Because I think this is just going to return the value of which one is higher or lower.
Yeah. Oh, you want the actual,
The
the reference to
Yeah.
which one was a higher or lower. But x1 and x2, but they're numbers anyways, right? X1 and x2 are numbers. So if you got the minimum one, the start's going to be a number.
So I would still need then an extra line then for maybe math.max. So that I can,
Yeah,
I know
so
this
you
is the
can
minimum
start-
one, but I don't know which one is the minimum one, if it is x1 or x2.
Oh, I see what you're saying.
So I still need something else. I
Because-
could do math.max to get the maximum one.
Because you want to start and an end so that you can
I
do
need,
the end. So you're doing math absolute to find the end.
yes.
Gotcha.
Yeah, I needed both lines. All right, well, now that I have my grid has a lot of elements in there. I'm gonna loop through the grid. I'm gonna filter out all of the ones that are not greater than 1, because that means there's no overlap there. If it's an empty element or if it is 1, I don't care about it. I just want the ones that are greater than 1. And then I'm gonna add those to my total count. And that'll give me the final answer. All right.
Looks really like mine. Just the fact I initialized.
I think you
the
initializing the
array.
array hurt you on this one, because yeah,
No,
the
the
inner
initializing
code.
the array shouldn't have mattered.
It's
It's the way you counted the array.
Yeah,
because I think I get same idea as what I've done on the day 4, where I created the array and then I like 10 by 10 and I put the stars.
Yeah.
And then I think I get screwed by that. I think.
I did have to pay attention while I was writing my code to make sure, like, okay, Y is for the vertical, Y goes down, so I need to make sure grid,
Yeah.
Y to get the correct row, and then X to get the correct element in that row.
Yeah, it's not XY like
Yeah.
we're normally used to in a Cartesian coordinate.
Yeah, we do remember, okay, this is my Y, Y's are my verticals, it's going down. All
Unless you
right,
rotate your answer.
I could, yeah,
But anyway,
all right, that was mine, and it worked.
Right,
And
I will go now if you guys
Okay.
okay with it.
Okay,
Right. So before I start my code, yeah, let me explain my process too. Is the real advent of code. So basically, you guys worked with array. I think creating the real array. What I worked with is indexes. So since I have the points, I wanted to count at which index lines, how many lines are there at each index. So I created a dictionary of every possible index. For example, I have an object in JavaScript or dictionary in Python with 0, 9. And I will look through if I found the possible lines or indexes that I will go through. I will check this index. Is it in my dictionary? No. So I will add this to my index dictionary and set the count to 1. So next time, is it in my dictionary? No. So set to the dictionary is this index to 1. So next time, let's say I come to 87 again in another pair. This is my dictionary. Yeah. So increment the count by 1. So I have 872 in my dictionary. So basically, I'm finding the horizontal or vertical lines with where each lines overlap, and I'm finding the minimum of either one. For example, here I have the y's, same, right? So I'm finding the minimum x, which is 7. Starting from 7, I'm counting towards 9, and I'm adding every index to my dictionary as I look through it.
Yeah. So you don't even
At
need a
the
count.
Yeah, I'm looking through it.
Because the question is how many is more than one. It's not how many were there.
Right.
So as long as there's more
so
than one, and an existence is one. So I think you don't even have to count.
So how do you get to 2 then? If you don't count?
But the question is not about how many were there, right? I think in the end, it just asks you how many overlapping points are there that have more than one, basically. So how many overlapping points are there? And so if you're just counting the points that already exist, then anytime there's an overlap, anytime there's a recall of the same number, you know that's an overlap. But you don't care how many overlaps there are. You don't care if it's 3 high or 4 high, or as long as it's more than one. But just being in your data structure is one.
Yeah.
Anyway, sorry. Continue on. I'm just
Yeah,
thinking
so-
on top of my head. That's a cool way to do
So
it.
yeah, if they are equal, my y's are equal, I start with x at 7. So count at 7, 8, 9,
Mhm.
and I add to my dictionary. If they already exist, I increment it. So after the looping is done, I filter my dictionary for the values which are higher than 1.
Mhm.
And I return the length of that array, basically. Yeah,
Cool.
okay. Now to the code. Okay. This is the part 1 of day 5. So first of all, I have my input. In my input, I have the values as a string 1 by 1. For example, this index is 1 item in my array. This is the second item, and this is the third item. So 1 by 1, everything is in my input at the beginning. So if I print it, as you can see, first item, second item, third, fourth, and so on, right? The next thing is to get rid of those items to those icons, or I'm looking through my array and pushing the first and the 0 index and the second index every time into a new array. So after this, I have an array of arrays in which every starting index and ending index is the index inside array.
Right.
So yeah, that's in my coordinates. So here, I have 0, 9, 5, 9 is inside array, etc. So now I'm starting to look through these arrays, and I will get my x1 and x2 by splitting and converting them to integer, y1 and y2. And I have an if condition here. So I'm checking if my x index equals to 1. If they are equal, I will find my minimum y and start in that index and get my maximum y plus 1 because it's exclusive. And after that, this is my dictionary coordinate set. So if this key exists in my dictionary, I will increment it by 1. Otherwise, it will set it to 1, this index, x1, y. Because x is same, I need to add my y's. They are the changing ones. And same for the y index. I get my minimum x, maximum x plus 1, and if they are not in my dictionary, set into 1, otherwise increment. So as a result, I have this set here. For example, I have 0, 9 index, 2 points or overlapping lines. At this index, I have 2, 2. This index, I have 1. This index, 1, so etc. And with my next thing, I get all my values into an array. So every count, I put them into an array and remove the ones which are smaller than 2, and returns the length of that array, basically. Yeah,
That's good.
that was my approach.
So
Part 1 was
good.
actually simpler. Yeah, part 1 was, I was able to solve it relatively faster, and part 2 took me really while because I got confused a little bit in part 2.
Okay,
Well done.
very cool.
Yeah,
Good job. I'm excited to see your part 2.
all right. Any questions?
No. Very good.
Right.
Clear. And I will share mine, which really isn't much different than the JavaScript approach that we covered today. Let's see where. Move over my screen before I share. Make sure nothing inappropriate comes out. My tab still says weekly sprints, but it's not, so I think we're okay. So for the day 5, I think it'll be pretty familiar. Essentially did something very similar where I created a field of values and then I incremented on those values and then I just counted how many were left. It's pretty much the same as the JavaScript that we've already covered. So the usual, I try to get all the coordinates in a format that I liked, and the format that I wanted was a matrix of numbers, basically a vector of numbers. So let's see, I have a lot of gibberish, but that's essentially what I'm doing, is just creating that matrix of numbers. I also, at some point, I guess I got min and max, but then I think that was, so this, I guess, well, going back to, yeah, Alexa's approach, I actually do initialize my entire field to zeros.
Okay.
So I create a vector, but initialize them all to zeros for however large I need my thing to be. And so I have this entire field of zeros. And then after I have the field of zeros, and then I do what's called drawing in. So now the code looks a lot like Scott's, where if it's a horizontal line, then I go ahead and increment all those numbers in the horizontal line. And then if it's a vertical line, then I draw along vertical lines.
What does a up caret mean on like lines 48, 49, and 50?
Oh, that's a bitwise swap. And so it allows me to change the value of 2 variables without using a temporary variable. It's not something that it's something that I wanted to do for fun. It's not something that I necessarily think that people should do, but there is a way to do value swapping using bits without using a third temporary variable. Okay, and with bit shifting. So if you haven't seen it, I encourage you to take a look, because it's kind of a fun thing, but it's not like it's going to make or break code. You can introduce a third variable without much cost.
Right.
But this is just a novel way to do it with only 2 variables, still being able to change the values between the 2 without a third variable. Using an XOR or not operators, or bit shifting. But I'll leave that to you to look at that. But that's what the symbols are.
Okay.
And that only happens if the same thing that you guys had, where like if you wanted to know which one was a lower value of the 2, and if it's the lower value you wanted to, or if it's like upper to lower, you wanted to like switch the 2 to also the lower. It's always going to be a range from the lower to the upper.
Yeah.
It's the same thing here. If the start is greater than the end, in other words, it's 9 instead of 7, and then I'm just going to switch the 2.
Right.
And that's
Okay.
that's what I did there with this fancy little novel thing. But anyways, after I create this entire field of zeros, and I go through and I annotate how, I just basically do a +1, right? So that's the plus equals 1 on any of those that I find. And
Okay.
then I just go through and I just count
So,
anything that's greater than 1.
so essentially the same as mine, except you had a field of zeros to start with. But okay.
Wow.
Looks,
So.
I needed some cool stuff in the middle.
Yeah. And I could do some printing out, but I mean, I think you guys get a pretty good idea. Let's see how large, I'm not sure, because my display is only 80, actually a little bit more than 80 characters across, but this is 100 characters across, so it's gonna look all like janky anyways. That's what this line does, is it helps me print out everything so it matches what I see in the question, so I can compare my algorithm.
Cool.
But yeah,
Are you getting more familiar with Rust?
it's getting a bit faster. I'm getting more comfortable with the different kinds of types that are available. Like there's a couple types of strings and they're incompatible, so you have to cast. There's a couple types of numbers and so on and so forth, and I have to figure out when to use what I've always considered references, but now I have to come with this new idea called borrowing versus ownership. And then there's life cycles for variables. So there's like all these new interesting concepts that, wasn't there. But now that I've done 10 days worth, I'm starting to become more comfortable with it. Now, granted, it also means that I'm like leaning on stuff I've already known. So like everything is done in vectors on mine, and I don't know if necessarily that's the best way to do it. I'm sure there are other data structures, like up till day 12, I think yesterday's, I started my very first hash map. So I got a little bit out of my comfort zone. So I'm still very much in the learning beginning processes, I'm sure. And I've looked through other people's Rust code, and I've realized, there's a lot of really neat ways people are going about solving the problems. And it's because Rust is also kind of like JavaScript in the sense that you can be functional when you want to be functional, you can be imperative when you want to be imperative. There's a lot of contention, whether people think, oh, we should do this on the imperative way. No, we should do this on the functional way. Versus Haskell, where Haskell was a clean, like there's only one way to do it. So it was like,
functional, right?
So there was still like, when I look at people's code, I'm like, oh my gosh, it's like 3 lines of code, but it's gonna take me 30 minutes to unravel it all. But it's mostly symbology and the rules of the language that I didn't quite grasp. Whereas this one, it's like, oh, okay, these symbology I'm starting to get used to. Some of the rules I'm starting to get used to. So it's kind of, I think it meets in the middle in terms of that. But most of my time when I compile my code, it's not a logic problem, it's casting problems. Like when can and can I not use a certain variable because either it's dead by the time I got to it, or it was pushed over to another function and never came back. So ideas of what's called borrowing versus ownership. And so those things are still kind of holding me back. Whenever I compile, it's almost always casting problems and ownership issues on variables, which is like, what does that mean? Coming from like JavaScript or Python?
the ownership of variables.
Casting, what?
JavaScript doesn't have ownership, it has freedom.
Yeah, and even with like C and C++, I mean, you can pretty much get away with just making pointers and just having like the program will compile, it'll just blow up when you run it. So having it catch at a compile time is kind of nice, but at the same time, it's a lot of scrolling of errors you have to fix in your first around your code. But anyway,
cool. Should we go on to part 2?
Yeah, let's go on to part 2. So while I already have this open, part 2, unfortunately,
not much to explain really for part 2. Part 2 is the same thing, except now we are considering the diagonal lines.
Yeah.
Before we just filtered out anything that was diagonal, we just ignored it. Now we're going to use the diagonal lines too, and we're going to do the same thing. We're going to find the number of overlaps.
And so let's see where my code changes on that.
As I didn't have time to go there, I was just thinking of it because I was like, obviously it was going to be diagonal after.
For now, ignore diagonals. Okay, we need it for part 2.
It's +1, right?
Yeah.
For the incrementation, I guess.
It's on 2. It's either +1, +1, +1, like +1x and +1 y, or -1x, -1 y, depending on what direction you want to go. Right.
It's nice though that every diagonal is pretty much a 45-degree diagonal.
Right.
So there's no weird slopes.
Like 30% slope or something like that. It's like over 2 down 1 or something.
It can be only 45.
Yeah. So they're nice. They're nice diagonals. They're not weird steep slopes or anything. They're all the same slope.
Yeah. As long as it's a whole number slope, it's okay.
Yeah, it has to be. Yeah.
It could be over 2 down 1, over 2 down 1,
over
2 down 1.
That's what I was thinking.
That's what it could be, but it's not.
Yeah.
This puzzle made it a little easier where every slope is
45 degrees.
easy.
So I pretty much, most of my code stays the same. I still initialize it the same way because I wanted a vector of vector events. And then my field still starts out with all zeros. The only thing I've added here is a provisioning for a diagonal. So the else if part here is the provisioning for a diagonal. This one I discovered Rust comes with a swap, so I don't have to do those weird little carrots that I did before.
Oh.
So the first part I left it as carrots because I was like, oh, okay, so we do it the manual way, but actually it comes with a swap. So I was like, oh, okay, I'll just do a swap then. One saves one line, and somehow the compiler will probably do a better job than I did of figuring it out. But anyway,
Cool.
that's all that does. That just replaces those little carrots that you were asking about in the past.
Okay.
But yeah, so this is just my provision for diagonals. Other than that, no, that's it.
All right.
And then so just go through the entire field, counting anytime there is more than one point, where each point has a count of more than one. So that's it. That's all I added.
All right. Well, I guess I'll share mine, and since mine was similar, just in JavaScript,
Sure.
with similar approaches. Let me share. All right, so here's my part 2. It was exactly the same for the entire top half. I had my horizontal lines and my vertical lines. And now here is my logic for diagonals from my else here. So a little bit harder to read, not as clean and efficient as Alex is, but it works here. So the nice thing about all of the diagonals is because they are 45 degrees, we can pretty much increment or decrement the X's and Y's together. So for example, if I start at 0, 0, and I have a diagonal line, I know that my next point is going to be at, well, I'm just going to increment. So X is going to be 1, Y is going to be 1. My next point will be 2, 2. Next point, 3, 3, until the end of the line. So the same thing I did for my other points here is I'm just finding out what that index is, and I'm adding that into my grid.
Ternary operators.
Yeah. They don't look so great when they're split onto multiple lines.
Well,
That's how my formatter did it for me when I saved here.
but I think for this case, because of all the X's,
Yeah.
and Y's and minuses and pluses, it does make it more readable.
Yeah, I should have. Yeah, actually, I meant to on my part 1, I actually went through and made it a little bit cleaner by adding in my y equals start plus j and x equals start plus j, but I didn't end up going through my day 2 to clean it up a little bit. So I could have cleaned all these up to just have y, x, y, x.
Sure.
That would have looked a lot nicer. I should eventually go back and do that. And same thing here, where I could just create my x and y variables to get rid of all of this junk. But it'll still end up looking very similar. Grid y, x equals.
Well, I mean,
y,
you can consolidate all your grid variables there into like point, because they're all the same.
Yeah.
Or what you're manipulating is the same. So in the top one, grid y1 plus j could become point, like 0.1.
Yeah. Or row.
Or row 1, yeah.
Yeah, yeah. That would be nicer. Yeah, it is all the same. But yeah, pretty much just have to loop through the length of that line too, and add each of those indexes into my grid. And at the bottom, the same thing. I'm just counting in my grid how many elements are greater than 1. All right.
Cool.
Right. Python or Alex, do you have something for part 2?
No, I already did mine.
Alexi?
Oh, Alexi.
I mean,
I
Alexi.
didn't reach the part 2.
Right.
Python.
Python.
Okay. So my part 2 is also similar to my part 1, basically exact same, except I have the third condition here, where I'm trying to catch the diagonal lines.
Mm-hmm.
So for the diagonal lines, the difference between x1 and x2 or y1 and y2 should be equal for them to be 45 degrees, right? The difference between them should be the same. Okay, so after that, what I have here is I have two different loops arranged together. So I have my range 1 and I have my range 2 merged with zip. So once I find the diagonal line, I have to find the, for example, in the example here, we have 9, 7 and 7, 9. So I have to find the basically direction, which way it's going to flow in each one, like which way it will go in X and which way it will go in Y. For example, here, X is going down from 9, 7, 9, 8, and 7, but the Y is going up. So we have 7, 8, and 9. So first I'm finding that direction by here I'm finding their sign direction by which one is larger. So based on one, for example, on x1, x2 plus 1, and the step here. So if it's -1, it will go down by 1 at a time. But if it's a +1, it will go up 1 step at a time. So I have two loops going up, or either one going up or going down. I have two variables here, I and j, and I'm adding those to my coordinates as before, as like others, those steps, those index.
Cool.
And the rest is exactly the same.
Yeah, you can tell the range whether to go up or down.
It took me a while until I find out about this zip. I didn't know how to loop through or how to join two loops together, because they are not two loops one inside another. They're loops that have to happen simultaneously. Yeah.
That's the cool thing.
So
Is that kind of thing possible in JavaScript even?
Should be. It's a functional thing. So it's like a fold, but simultaneously. Two sources.
That's cool. And thank you for explaining a little bit more about the diagonal lines and their directions. I kind of skipped over that in my code a little bit. I had a lot of if-else conditionals to determine if it was going down or
that's actually how I had it in my first efforts too, in this part 2 of day 5, but I couldn't get it to work basically on Visual's. I had one loop inside another, and I tried a lot of the steps, but I couldn't find it until I found this joining the two loops together. Then it was simple. Yeah.
I just had a single loop, but a lot of conditionals inside to determine if X needs to increment or decrement, and if Y needs to increment or decrement. I think I checked my Y values first. I checked if Y1 was greater than Y2, and then I did one block of code if that was true. And inside of that, I had a conditional for my X's if X1 was greater than X2. And yeah.
I aligned
nested conditionals.
Yeah. Instead of doing two conditionals on the X and the Y, I made sure that my X always went from left to right.
That's nice.
But then I only have to worry about the Y's. Is the Y is going to go up or the Y is going to go down? But I made sure that the X's, that's my swap. I make sure that the X's are always going to go up. Because, whether the line goes this way or whether the line goes this way.
You can always start on the left side.
Yeah, you can start on the left side. Even if they give the coordinates from this side going down to there, it's the same line as going from this side up to there. So I made sure that they all, on an X, Y basis, went positive, and then just have to worry about whether the Y's went positive or not.
Cool, cool.
Right.
Anyway,
yeah,
looks good.
Okay.
So again, I think, going back to the earlier thought I had based on Farouk's approach, I think we could have, because at least you and I, and you as the original approach, we thought, oh, we'll just create the grid, draw on it, and then count afterwards how many of these points are critical. So you create all these extraneous points, but I think, Farouk's approach of just creating the points is kind of an interesting approach. And I would take it even a step further and saying is, I think Farouk, you still counted on each one of those, maybe because you were waiting for a possible part 2 where it was relevant, whether it was 2 or 3 or 5 or 20. But it ended up not being relevant at all. It just has to be greater than 1,
Right.
which means that we just need to keep track of which points had a point already. And anytime a point is reused, that's count plus 1, right?
Mhm.
So could have been another approach. Of course, then we could draw our nice little drawings. Or maybe we could have, but it's been more complex to draw our nice little drawings instead
My
of just
drawing-
dumping memory.
My drawing didn't even look nice because it just said 7 empty objects,
Oh.
1.
That's true, you had
3
a-
empty objects, 2. Like,
You had this
mine
one, too.
didn't look beautiful. It was, but when I saw it, I could read. Like, it was easy for me to put that together and look at the sample
Mm.
on the website and see, okay, this matches up.
Mhm.
Because I had
Okay,
7.
so Alex, your suggestion was as soon as one of the indexes increment from 1 to 2, add that to a different array and do not keep the track of it anymore.
No, as soon like let's say you have from like 1, 2 to like 5, 2, right?
Yes.
So 1, 2 to 5, 2, you know that the 2s are common, so it's out. So it's a horizontal line from 1 to 5. Okay.
Yeah.
And then so you take all those points and you put them in the array like you did, where you have an array of points that are occupied. And so
Yes.
now 1, 2, 2, 2, 3, 2, 4, 2, and 5, 2 are in this array.
Yeah.
And then you go process the next line of your input. And let's say it's a horizontal line. And then so those points that are horizontal, let's say it's 3, 3, 7 to 3, 9, right? So there's 2 points, 3, 7, 3, 8, and 3, 9. Are they part of your already existing points that are known? If not, you just add them, 3, 7, 3, 9, or 3, 7, 3, 8, and 3, 9. And then later on, if you ever get a line that crosses through one of them, you're gonna, when you do your test, let's say you do a test and now you have maybe at the 2 points, so you have 1, let's do another horizontal line, 1, 2 to 1, 2 to 1, 5, say, right? 1, 3 is already in there. So you got 1, 2, 1, 3, 1, 4, and 1, 5. You check to see if any of those are already inside the list or inside your points, your occupied points.
Yeah.
1, 2 is not, so you append that. 2, 2 is not, so you append that. Or what am I saying? No, 1, 3 is not, so you append that. Wait, 1, 2 is not, so you append that. My numbers already get mixed up.
It's a lot
But-
of
1, 3 is there.
But 1, 3 is there, let's say. Let's say 1, 3 is already
Yeah.
there. Then you increment your a count that you have, a universal count of how many are already more than 1.
We
You
have a
just increment
problem,
that
though.
1.
If multiple lines intersect, then it will count the same point more than once. For example, if 3 lines intersect on that same point,
That's
then
true.
that line will get counted more than once.
That's
So I
true.
think it does need to keep it the way it is with his count inside the object. So that you can, so that if it's 2 or 3 or 4, he can just count that as a single time. I
Gotcha.
think if he kept a running total count, then it would add.
Yeah.
So unless you have another array that only keeps track of ones that have been counted twice
That could, yeah.
or
Compare
counted
it
multiple
against that.
times, right? That's already counted against the total. Because then you can check to see if it's a part of the first one. If it's not part of the first one, then you check if it's an already counted one.
Mm.
If it's not part of an already counted one, you add it to the already counted one.
Mhm.
If it is part of the already counted one, then you just ignore it because you don't care if it's more than 2, and then you just count the size of that second one.
But at that point, I'd start thinking that maybe his approach is easier. We're just incrementing it
Yeah.
in the
Yeah,
dictionary.
conceptually, it's much easier.
Yeah.
But in terms of
I
like
think
or the data structures that you have in storage are much simpler because now now you can just get rid of stuff.
Oh, okay.
And one of the things we can get rid of is the fact that we don't care if it's 2 or above.
I was confused a little bit at your suggestion, but now, yeah, I understood. Okay. Keep count of the indexes with their incrementing, their count is more than 1. That was your suggestion, right?
Yeah, and then Scott also pointed out correctly that then we won't know if we double counted particular points that that line intersects a third time. But you can still then do another, so one array of ones that are singly occupied and ones that have already been counted as multiple occupancy.
So that you don't count them again.
So you don't count them again. And you just get the length of that second array. But anyway.
I like talking about different approaches. Because usually my mind just pigeonholes me into one single approach. And I'm like, this is the way we're doing this. And yeah, even like Alexi, if I close my laptop, come back later, I do the same code because my mind thinks in that one direction. So it's nice to hear different ways to think about this, different approaches.
And one of these, day 6, you're gonna find, I guess, where I couldn't get out of the rut. And so I have about 2 pages of commented out code.
Yeah, I agree with you. Well, I thought it would be super quick the second part. It didn't go quick at all. I remember now.
But we'll see that in the next.
Okay, my approach actually, I was familiar with an approach called frequency counter. Yeah, what I used is there is an approach actually in problem solving called frequency counter. So yeah, I had familiar with the approach, and this is that approach. So you keep count of whatever you want to keep count in a dictionary or an object, and you filter it out or do some manipulations with it once you get your data. A frequency counter approach. If you want to have a look, Scott.
Okay. Interesting. Cool.
All right, guys. So that was day 5. And I guess we'll see what day 6 is like. So we'll see you guys again on Wednesday. We'll cover the next 2 days of questions and cover day 6, which should be fun. All right.
All
right. Happy coding.
Happy coding.